Hey guys, this video is about the history of the atom, including two very important scientists, Democritus and John Dalton. So now, the thing is, how can we relate this topic to your guys' lives? Well, the scientists were struggling to look at what is inside what makes up matter, which is what's inside atoms, and it was a little complex, tricky thing to discover. Okay, now think of a gift that you could possibly get, um, especially if it's wrapped. If it's wrapped, there's no way to really determine what's in it. Some things you can determine, like the density of it, how heavy it is. Is it rolling back and forth in the box? Is it shaking in the box? Does it feel light? Okay, so you can get some key indicators based on, what you're feeling. Well, scientists can't do that. They have to measure it and observe um, what they're testing. Okay. Now, inside matter, the smallest workings are not distinguishable to the human eye. We can only test and hypothesize what the internal workings of matter really are. So there's a few models we're going to look at in the development of the actual atom, but we're going to start back at where all this began. So we're going to rewind back in history. So let's look at the early models of the atom. Now, what is an atom? Well, an atom is the smallest particle of an element that retains its identity in a chemical reaction. The word atom comes from the Greek word meaning indivisible. So you cannot break an atom down into any smaller parts than what it is. So an atom is the smallest starting point of all the elements. It's the smallest little structure. Okay, now early scholars were intrigued by the concept of the atom. They could not observe individual atoms. They proposed ideas about the structure of atoms, and it eventually led into the particle theory of matter, which is something you'll learn down the line, okay, especially in physics. Now, continuing, one of the first people that go down in history regarding the atom is Democritus. Democritus reasoned that atoms were indivisible and indestructible. He was a Greek philosopher and the first to suggest the existence of atoms. Now, the downside to Democritus is that he could not prove his philosophy. He was unable to explain the chemical behavior, and he lacked experimental support because he was unable to test. They didn't have modern day testing. Now, moving down in history, the next important scientist uh, comes from Dalton's atomic theory. His name is John Dalton. He began the modern process, the theory of discovery regarding atoms. He was a teacher slash scientist, and he studied something very important. He studied the ratios in which atoms combine. Okay, that's very important. So if you look at this equation right here, you can see you have two irons attached to three oxygens. Every time iron is oxidized, you get this formula. And he studied many other ones too. Okay, John Dalton, using experimental methods, transformed Democritus's idea on atoms into a scientific theory. And he had four parts to it. Some books say five, but there's four main parts. Okay, the first part is all elements are composed of tiny indivisible particles called atoms. All right, the second part is atoms of the same element are identical. The atoms of any one element are different from those of any other element. So like, let's just say you had silver and gold. They're going to be completely different. Third part is atoms of different elements can physically mix together or can chemically combine in simple whole number ratios to form compounds. So elements are going to come together to form new substances, which are compounds, and we're going to discuss that down the line in great detail. And the fourth one is chemical reactions occur when atoms are separated from each other, joined, or rearranged in different combinations. Okay, now, what is the size of an atom, since they are very tiny? Well, the diameter of all atoms differ. Some are extremely small, some are large compared to each other. The average range is from 0.1 to 0.5 nanometers. Now, a pure copper coin, if you lay it on its side, the size of the penny contains about 2.4 times 10 to the 22nd atoms if you were to lay them next to each other. By comparison, Earth's population is only about 7 times 10 to the 9th people. That's a lot of people. It's like 7 billion people. If you could line up 100 million copper atoms side by side, they would only produce a line only 1 centimeter long, and that's as wide as my pinky. Okay, so they're extremely small. Now, if you have the opportunity to go online and look up, or even later on, to use a scanning electron microscope, this is basically what you're going to see. You're going to see how the atoms are all lined up nicely. You're going to see individual spheres all connected. Now, what you're seeing here is a display of their energies, and it's forming this molecule, and it's computer processed so that we can see it. Okay? All right, guys, that's where we're stopping.